Okay, morning guys. This is, well, it might be afternoon or evening when you're watching this, but anyway, for me it's the morning and I'm just about to do example 9. Now that's not the example 9 that are in your textbooks. The online version has got an extra question in, which when I came to look at what to do next was there. So I'm going to go through that as an extra example. And then at the bottom of this same page, there are two questions which fit with that, which I will then put up on the screen, which is what I want you to do, and then stop it there, and you'll need to log on again. And I've put the answers to these questions also at the bottom of the end of this clip. So we've got an example, then there'll be two questions for you to try connected to it, and then the answers to that to look at the end. So how you organise your time is up to you, but the best way is to watch the question, the example, do the two questions and pause it while it's paused, and then go down, look at the answers. Okay, so here we go. A uniform rod AB of mass 6 kilograms and length 4 meters is smoothly hinged at A. So if we lift out the key information, we've got 6 kilograms, it's a uniform rod, smoothly hinged at A and length 4 meters. It's light and inextensible. A light and inextensible string is attached to the rod at point C, where AC equals 3 meters, and to a point D vertically above A. If the string keeps the rod in equilibrium in a horizontal position, so it's equilibrium, it's horizontal, the angle between the string and the rod, is 40 degrees. Okay, so let's draw that. So we've got a wall, a hinge, a rod, and then a string coming down at 40 degrees to the rod, and that's A. Rod is 4 meters long, so we've got a distance 3 meters to C, and then another meter. So that's 1 meter, that's 3 meters. And we've got our point C here where the string is attached. Okay, what else do we know? The mass is 6 kilograms and the rod is uniform. So we've got a weight of 6 kilograms. So we've got a force acting down here, 6G, and that length will be, as it's a uniform rod, 2 meters. Okay, what other forces are acting on this system? Well, we've got a tension in the string, and we've got a force at the hinge. Let's call the horizontal component of that X and the vertical component of that capital Y. Other letters can be used, it doesn't really matter. Some people use H and V. I tend to use X and Y, but it doesn't matter. So we've got that as our diagram. Notice the forces that I've put onto the diagram are all the forces acting on the rod, not the forces acting on the string or the forces acting on the wall. Yeah, it's the rod that I'm interested in, so it's the forces I've drawn on are the forces acting on the rod. Because each one of these will have an equal and opposite kind of thing going on. Every action has an equal and opposite reaction. Okay, so it's a statics problem, so we should know what to do. Yeah, three things. Just think for yourselves what they're going to be. Yeah, it should be the things we're thinking about doing are resolving horizontally, resolve vertically, and moments about point where most unknown forces act, unless we're looking about for the distance from a point, in which case we would take moments about that point. But we're not looking for a distance here, we're looking for the tension and the magnitude and direction of the force exerted on the rod by the wall. So they're the two things we're asked to find. So it doesn't matter which order we do these three things in, we're likely to have to do all three. So let's just start at the top. Resolve horizontally. So we've clearly got X, and the other one that's got a horizontal component is T. So we need to break that down into its components. So T has got a vertical component. That's opposite the angle. So that will be T opposite is sine 40. Okay, we've also got an adjacent part. And adjacent we've got here. And that's going to be T next to the angle, so it's cos of 40. Okay, so we're working horizontally, so we need to pick out that force and that force to give us this line. So we're going to have X minus, and we want the horizontal component of T, which is T cos of 40 is equal to 0. So X equals T cos of 40. Not much else we can do with that. We've got one equation, two unknowns. So let's just carry on through our routine. Let's resolve vertically. So if we look at our vertical components, we're going to have vertically 6g, T sine 40, and y. So that's y plus T sine of 40 minus 6g equals 0. Yeah. So that's that bit. They're both equal to 0 since equilibrium. Since equilibrium. Okay, so again, we've got one equation with two unknowns. So if we tidy that up, we've got y equals 6g minus T sine of 40. Okay, let's go back to the question. What have we been asked to find? We've been asked to find the tension. Well, neither of those go with tension, so let's now try our last thing. Take moments about A. So that means X and Y are eliminated. We're going to have our anti-clockwise component about A, which is our force. Here, that's going to have a turning effect. And the other one that's going to have a turning effect is the 6G. All the others act through A, so they have no turning effect. So these two, T sine 40 and 6G, are going to have the turning effects. So let's have a look at the anti-clockwise one. That's the t sine 40. So t sine of 40, and its perpendicular distance to the line of action is here. Whoops. Undo. That's not right. Okay. Let's try again. So T, although I've drawn it there, it's actually all the way up here, isn't it? It's acting at this point C. Yeah? So it's acting at point C. So we've got T sine 40 times by 3. So 3T sine 40. In the anti-clockwise direction, we've got our 6G, and that is acting at its middle. So that is going to be 2 times 6G. The distance is 2 and the force is 6G. Well, that's enabled us to get T straight away, hasn't it? Yeah, so T is equal to 12G over 3 sine of 40 is 4G over sine of 40, which we can tap in the calculator, but that's sine 40 is roughly root 2 over 2. So that would be 8 over root 2 or 4 root 2G. So roughly 5G, around 50, 60-ish. So let's tap that in the calculator and it comes out to be 61 newtons, there or thereabouts, for T. Now we've got T, we can substitute back in to get X and Y. Yeah, so we can substitute in for T, back up here. Yeah, so T equals 61, we can substitute it in here and in here. Yeah, so we're subbing 1 and 2, if we call these equations 1 and 2, sub in 1 and 2 to find T. Sub in 1 and 2 to find X and Y. Okay, and we're needing to do that because the question said, find the magnitude and direction of the force exerted on the rod by the wall. So we're looking for X and Y to find part B. So we're into part B now. So into part B, and we're going to sub in 1. So sub in 1. And X, tap it in the calculator, and we get roughly T is roughly 4G. Yeah, because, cos 40 over sine 40 times 4G. So 4G cos 40 over sine of 40. Well, if it was 45, cos 45 over sine 45, that would be 1. So cos 40 is slightly bigger than sine 40, so a bit more than 40. Tap it in the calculator, comes out to be 46.7 newtons. Y? Well, Y is 6G minus T lots of sine 40. So minus 4G over sine 40, which is t, times sine of 40, which gives us 2g, which is 19.6 newtons. Okay, but that's not all. The usual thing, go back, read the question, check you've answered it. The magnitude and direction. So the magnitude of the reaction is x squared plus y squared square rooted using Pythagoras. So we can just then put those in. We've got 19.6 squared plus 46.7 squared square rooted. So 20 squared is 400. 45, it's going to be a little bit bigger than that. So say guess 50-ish. Tap it in the calculator and we get 50.7 newtons. And lastly, direction of the force exerted on the rod by the wall. So if we have our wall, we've got x, which was 46.7, and our y is 19.6. Okay, notice how I've added them up. So nose to tail. As usual around here, yeah, it's nose to tail. So that gives, when I add them up, I get this as the direction of my reaction with the wall. So tan theta, tan as it's the opposite, 19.6 over the adjacent, 46.7. So theta equals arc tan of 19.6 over 46.7, which comes out to be, tap it in the calculator,